Today we're looking at a 77 911 Targa. This has been one of our longer term customers and we're getting the car ready to sell. The fuel pump's been making a lot of noise. It's had 3 fuel pumps thrown at it, so it's coming and going with the noise. Sometimes it's louder than others. So I'm just going to do a couple of voltage tests, make sure we're getting good voltage down to the fuel pump. We'll take a look at current draw, kind of get an idea on what could be possibly making this pump noisy.
What makes it warm?
Both.
Oh.
And really pump, electrical pump.
Pretty good. Okay, so what we're looking at is voltage drop across the circuit. When I put my voltmeter on both sides of the fuse, we're losing 0.038. When I first looked at it, it was 0.04 of a volt, and then I just twisted the fuse a little and it dropped. So that's indication of not the greatest contact. I'll pull it up, the fuse, and clean it and put it back in and retest it. Probably replace the fuse just for good luck. But really 0.04 of a volt is not much of anything. Okay, battery terminal is good. So this is doing the same test on our battery terminal, measuring from the terminal to the post. 0.001, good connection. Do the same here. Ground terminal, same thing, good connection. Let's go directly to these cables here. 0.002 onto our accessory cables. Still no cause for alarm, 0.001. Main battery cable, 0.05 and fluctuating. That could indicate a little bit of corrosion between the battery terminal and the actual wire right there. So we're just going to check it to ground and move on. Okay, a little bit higher, 0.024, 0.025. That's going from battery negative terminal to the body. So we're losing something through the cable there. Yep, a little bit in the cable and a little bit in the connection. So probably time to put a new ground cable on it to rectify.
It's getting noisier now. See, test it now because it's just gotten noisier.
Okay, we're losing across the fuse. About 0.05 of a volt across the fuse. 0.3 of a volt from the battery positive to the fuel pump positive.
Which one's the relay for the fuel pump?
This one.
Okay. Lots less. Oh no,
No, it's
it's pretty
higher.
bad. Yeah.
It's half a volt.
CIS needs fuel all the time. Oh, do you want me to turn the ignition off?
Go and start it again.
Okay.
Alright, so I've just cleaned up the terminals, put a new fuse in, and my voltage drop across the fuse has gone from 0.3 something to 0.036. So considerable difference there. Still hasn't resolved that pump squealing. I think the next thing to do is start looking at fuel pressures and fuel filter. Okay, so what I'm going to do here is I'm going to check our fuel pressures and how many amps the fuel pump is pulling.
And to do this, I've bridged the fuse. I've removed the fuse, and this jump wire is going to carry the current going to the fuel pump. Fuel pump should pull around 8.5 amps is the maximum according to the factory information. And that'll give us an idea on how well the pump's working. If amperage is high, it could be an electrical problem or it could be a pressure issue. So we're going to try and look at a lot of different things at once. Okay, so I have my fuel pressure gauges on the car. And first thing I need to know is the exact temperature of the warm-up regulator. So I'm using a Raytec gun, and I'm set to degrees centigrade, and so it's 20.2 degrees. So now I can see what my cold control pressure is going to be. Warm-up regulator is 033 warm-up regulator, 20 degrees, low side 1.8 bar, high side 2.2 bar is what we're looking for. Okay, check system pressure, and we've pegged my gauge. So I'm going to take a look. Okay, so I'm going to take a look at our return line and see if we have either a blockage in the car or the piston sticking in the fuel distributor for control system pressure. Okay, so what I was doing there was looking at my warm control pressure, and it was heating up. When you saw the needle jump, I was pulling off the vacuum, which increased the control pressure as if it was acceleration enrichment. But when I went to the front of the car and I took a look at the amp gauge, I was back up to 14 amps. That's why I swung my pressure gauge over, and max pressure had pegged again. So it looks like there's something a little bit deeper in on the fuel distributor that's causing that pressure relief valve to get stuck and is causing it to make the pump whine because the pump's working way too hard. So I pulled the pressure control out of the back of the fuel distributor. Piston looks good, came out easy, just used a magnet. And spring, I mean, everything seems normal. Looked in there with using a mirror and my flashlight. It's right on the back side of the fuel distributor. The cylinder bore looks good, no scoring, no major issues. So let me put it back in and see if there's any change just pulling it out. Oh, that's more normal. Still on the high side. 5.1, 0.2, 0.3, 0.4 bar. Usually we want to see that a little bit lower. Didn't see any shims in there that could change that. So, but it definitely looks like the pressure regulator might have been sticking. Let's go take a look, see what our current draw is. Oh, our current draw is now back to 8.6, which is 8.5, which is exactly what Porsche says maximum current draw should be. So what this confirms is the fuel pump is most likely fine. When it's screaming, it's because it's working too hard. The system pressure being right up there at over 1,000 kPa, so it's right up there. Just a matter of tracing it down. I need to pull the return line, just make sure there's nothing in the car that's causing that pressure spike. So we're going to do a twofold test here. I've got the return line piped into my bucket, and I'm going to do two things. I'm going to measure the amount of fuel returning as well as checking my pressure, and seeing if it is normal. If the pressure is normal, then it may be a downstream problem with an intermittent blockage on the return line, and I need to go look for something that's crimping it or some issue like that. Okay. Very dismal response. That's all we got in 30 seconds. We should be looking at at least a quart of fuel in 30 seconds in the return. So that means there's nothing wrong from this point back to the tank. The problem is either fuel distributor related, or I'm going to just follow here, make sure there's nothing weird on the return line where it attaches to the fuel distributor, but it looks more and more like the issue is going to be a fuel distributor issue. Okay, round 2, I changed the O-ring on the front of the piston because it looked like it was a little swollen and too big. And now we are getting lots and lots and lots of fuel on the return side. Pressure is still a little bit too high for my liking, so I'm going to change the copper seal ring to reduce my system pressure. Okay, so system pressure on these cars should be, the test specification is 4.5 to 5.2. I believe I put a new O-ring on the pressure relief valve because the O-ring looked like it was kind of swollen and big. And that seems to have corrected a lot of issues, but my system pressure was still too high. Adjusting pressure, so ideal adjusting pressure is between 4.7 to 4.9 bar. And so we're just going to power up the fuel pump and look at what our pressure is and our current draws. So right now I'm coming in at 4.8 bar. There's 4.5, 4.6, 4.7, 4.8. So right in my sweet spot for fuel pressure. And this is system pressure with the valve closed. Fuel pump is much happier, running at 7.2 to 7.5 amps. And is nice and quiet as it should be. And rest pressure is sitting quite nicely. Okay, so the next thing I've got to do now is take a look and see what my control pressure hot is doing. Now, before I was seeing a much higher number. I was seeing right up around 4.5 bar of hot control pressure. But if my system pressure is so high, it's not an unexpected thing to see. So I don't want to blame anything on the warm-up regulator until I can re-verify. So I'm going to start the engine, let it run, let it warm up, and see how it's doing. Okay, so my control pressure hot is just about 4 bar or so. The spec is 3.8 on the high side, so I'm not going to worry about it for a 0.2 of a bar. I also have good response when the vacuum comes off. It drops right down to 3.2. You hear the engine rev up because it's enriching. So I'm going to go ahead, reset my fuel mixtures, and then probably take the car for a test drive. Wow, it's so rich.
That number or that number?
This is the number I'm looking at.
Oh, that's supposed to be around 2?
Yeah, we want this 1.5 to 2%. HCs, it's actually burning it all. 173 is actually running really clean. CO2 we want as high as it can possibly be. 10.6 is actually not that bad, but as we lean it out, we should see our CO2 numbers come up. O2's around 0.5%, so not a lot of oxygen left. Normally I want to see around 1.5. Air fuel ratio we're looking at, but I don't really care. It doesn't give me any actionable information other than we're running at 12 to 1. Same with lambda. Lambda should be as close to 1 as possible, though at idle it's going to be below that. This is just showing that it's rich. These 4 numbers up here are what we are interested in, and this is why you can't do this job with an air fuel meter. Telling you it's 12 to 1. If you read some information at idle, people will say that's great. On some cars it may be, but not on these.
So we've got CO at 2%, hovering around. That's really nice. Hydrocarbons at 96. This car does not have a catalytic converter, and that's as clean as a lot of catalytic converter cars. Our CO2 number has come up to 13.79, 13.8. That's awesome. Usually that's an indicator of how well the engine is working. So if we look at all of these numbers, they paint a picture. O2 is still nice and low. That means we're burning all of the available oxygen that we're putting in, and we don't have any exhaust leaks. It can be a little bit higher. As I said, up to 1% is not a bad thing as long as your hydrocarbons are nice and low. CO2 is, as I said, it's a measure of how efficiently the engine was working. We started off in the mid to high 10s and we're in the high 13s. That's great. CO is right in our adjustable range. Hydrocarbon, this is fuel coming out of the tailpipe. This is fuel going in the engine, coming out. So it's burning all of the fuel that we're putting in there. So basically it tells you that A, your settings are right about where they need to be. Means your engine is working well, compression's good, valve timing, engine mechanical is in great condition. So I'm going to shut it all down, get all of my equipment off, and we're ready to test drive. Okay, our fuel pump is still doing good. It's hovering around on amps, but right at that 8 range, so that's doing well. I've added 2-stroke to the tank as well as a fuel conditioner. You can see I got my little funnel right there. 2-stroke oil helps lubricate the pump and lubricate the parts in the fuel system, and the conditioner, because these cars sit around more often than not, helps to stop that fuel going stale. So all in all, I think we have resolved the running and fuel pump noise issues.